Okay, so ladies and gentlemen, welcome. So in today's lecture, we are going to solve some of the questions that we started in our last videos in Physics 131, which is heat and properties of matter. Don't forget that we have discussed about heat capacity, specific heat capacity, heat and temperature. We also talk about thermometer and different types of thermometer. So this is actually some of the questions that are associated with the thermometer. So we are going to solve some of these questions. And don't forget that if you didn't join the YouTube community, try to join it so that at least we have access to most of our videos. So the question says, a gas thermometer is used to measure the temperature of furnace and indicate the ice and steam as 27 millimeter mercury and 90 millimeter mercury. Then at what temperature would each record 55 millimeter mercury? So this is actually simple. So we are going to start with the solution. We are starting with solution. So now, when we say something is ice, like for example, so ice means something at 0 degrees centigrade, especially like water. For water to become actually ice, it has to be at 0 degrees centigrade. So therefore, ice, which is 0 degrees centigrade, is equivalent to 27 millimeter millimeter of mercury. And then, of course, for steam, which is extreme, is always at 100 degrees centigrade. So at 100 degrees centigrade, we have a pressure of 90 millimeter mercury. And then, of course, at what temperature would it record 55 millimeter mercury? So if at 0 degrees centigrade, we have equivalent to 27 millimeter mercury, and at 100 degrees centigrade, we have equivalent of 90 millimeter mercury. Then, what temperature would be at an equivalent of 55 millimeter of mercury? So to actually get our value of x here, what we are going to do, we are now going to say x minus 0. So we now have x minus 0 divided by 100 minus 0. So we have x minus 0 and 100 minus 0, which is equal to, also for this one, we have 55, we have 55, we have 55 minus 27, and we have 90 minus 27. So x minus 0, we have x divided by 100, which is equal to 55 minus 27, we have 28 divided by 63. So therefore, we are now going to cross multiply, which at the end is going to give us x is equal to x times 100. Sorry, 100 times 28, we have 100 times 28 divided by 63. So 100 times 28 divided by 68 is going to give us 44.44 degrees centigrade. So this is actually the answer to this question. So please, ladies and gentlemen, don't forget to follow and join the YouTube community. So look at the steps. So now let's actually look at another question. Let's look at another question. So example 2. The resistance of a platinum resistance thermometer at 0 degrees centigrade is 5 ohm. So you see in this case, you have the resistance at 0 degrees centigrade. So the resistance at 0 degrees centigrade is equivalent to 5 ohm. It's equivalent to 5 ohms. And then and at 100 degrees centigrade, which is at extreme 100 degrees centigrade, is equivalent to 5.39 ohms. And then when the thermometer is put in hot bath, the resistance of their platinum wire is found to be 5.39 5.795 ohms. And here we have X, because we want to get the temperature of the bath. So to calculate the temperature of the bath, we are going to start with X minus 0 minus 100 minus 0 is equal to, sorry, X minus 0 divided by 100 minus 0 is equal to 5 point, is equal to 5.795 minus 0 minus 5 divided by 5.39 minus 5. So therefore, this minus this we have X divided by 100, and this minus this we have 0.795 divided by this minus this, which is 0.39. So we're now going to cross multiply, which will give us X is equal to 100 times 0.795 divided by 0.39, and this will give us 90. This will give us 79.5 divided by 0.39. So this divided by this will now give us X is equal to 203.85 degrees centigrade. So this is the answer. So ladies and gentlemen, please don't forget to join our YouTube community. And of course, there are some videos that are related to this topic that you have to watch after you join the YouTube community. Please try to join us. Thank you.